Hi guys, happy Tuesday. Today we are going to be introduced to acids and bases in the notes. Yesterday we reviewed just naming them. So today we're going to actually talk about all that stuff on that first slide, like what is an acid, what is a base, what does that mean? So you should have out notebook paper for sure to be taking notes on because this is definitely new stuff. So properties of acids. Acids usually begin with an H. They taste sour. They turn litmus paper red. They turn pH paper red. They react with metals to produce hydrogen gas, which is explosive. They will conduct electricity. They have a pH less than 7. And when they react with a base to form salt and water. Some common acids, acetic acid is vinegar, like vinegar that you clean with. Carbonic acid is in sodas. Hydrochloric acid is in your stomach. Nitric acid is used in fertilizer industry. And sulfuric acid is battery acid. You don't need to know these. This is just like, hey, what do you know? Bases. Bases are the opposite of acids we said yesterday. They produce OH. And yeah, they usually end with OH. They taste bitter. They turn litmus paper blue. pH paper violet. They feel very slippery. They will conduct electricity. They have a pH greater than 7. And with an acid, they'll form salt and water. Some bases. Soap, drain cleaner, sodium hydroxide, those are bases. Potassium hydroxide. Calcium hydroxide, magnesium hydroxide. Magnesium hydroxide is in Tums, one of them. Go look at the labels. Ammonium hydroxide is in a lot of cleaning solutions. So a lot of cleaners and stuff are bases. Bleach is a base. Acids are not the only dangerous things. You do not want to drink bleach. You will die. It will most definitely hurt you. Bleach burns are very real. Yeah. Okay. So some definitions of acids and bases. The Arrhenius definition. This is the oldest one and the less encompassing. It doesn't include every acid that there is. So it says an acid generates H plus in solution. H plus is known as a proton. If I say proton, it also refers to a hydrogen ion. And why that happens really fast. So we think about hydrogen. Hydrogen has 1 proton, 1 electron, and 0 neutrons because its molar mass is 1.0008. So really there's not a neutron because this mass is 1. It comes from the proton. So when it's H plus, that plus charge means it lost an electron. Remember, positive, it's positive, it lost an electron, so there's not an electron, there aren't any neutrons, so really it's just 1 proton. That's why you'll see a hydrogen ion called a proton. Those words are interchangeable in the case of this. And so here's an example reaction. Hydrochloric acid, when it's put into water, it will separate into H plus and Cl minus. Bases generate OH in solution. OH is a hydroxide ion, and so an example, sodium hydroxide, when you put it in water, it dissolves into Na and OH. The Bronsted-Lowry definition. This is a more modern definition and it can be a little confusing. So an acid is any substance that donates or gets rid of H plus or proton. So HCl is still an acid. It gets rid of the hydrogen. Bases are any substance that accept H plus. And so looking at this reaction, NO3 plus H makes HNO3. This NO3 accepts or it has the H join it, so it is considered a base. Nitrate, I want a pen highlighter, is the base in this case because it accepted or took that H plus. And so with Bronsted-Lowry acids and bases, we have things called acids. Well, you have an acid, you have a base, and then you have something called a conjugate pair. I didn't want that in red. I wanted that in yellow. The conjugate pair is what we're going to label on the product side. You have a conjugate acid and you have a conjugate base. And so we will be writing these reactions and labeling your acid, your base, and then your conjugate acid and your conjugate base. It's important to remember that the acid is always on the reactant side, and it's the one that donates or gets rid of the H. The base is always on the reactant side, and it's the thing that's going to accept the H. And then the conjugate acid and base is going to be what's on the product side and what is left over, which I know you're really confused right now. And so we're going to look at this reaction. So here we have HCl plus NH3. HCl is going to get rid of a hydrogen because on this side it's Cl minus. It donates or it gets rid of the H. So HCl is my acid because it gets rid of H. Now, looking at the right-hand side, NH4 positive compared to NH3 positive. NH3 gains an H on the right side, so that means this is the base because it's going to accept the H. So my acid and my base, those get labeled on the left. The acid is the one that's going to get rid of the H. The base is the one that's going to take the H. Now on the right-hand side, we label them conjugate acids and conjugate bases. And the acid on the left becomes the conjugate base on the right. They are opposite. And then the base on the left, NH3, becomes the conjugate acid on the right-hand side. So they flip roles. HCl is the acid, it becomes the conjugate base. The base becomes the conjugate acid. And why that happens is if we reversed this reaction and it was NH4 plus Cl makes HCl plus NH3. Let's say we reverse this reaction. NH4 becomes NH3. And how does it become NH3? It gains or loses an H. It loses an H. So if you reverse it, it's the acid now. It's going to lose the H. And Cl, when you reverse it, will gain the H, which is why it's the conjugate base. So pretty much, if you can remember that whatever is the acid on the left, it becomes the conjugate base on the right, and then the base becomes the conjugate acid. They flip roles and throw that word conjugate in front of it. And I'm going to erase this. So just repeating what I said, when the acid on the reactant side loses a proton or an H, it becomes the conjugate base. Acid becomes the conjugate base. The base gains the H and becomes the conjugate acid. So we're going to, and you're going to have to do this on the worksheet tomorrow, so you definitely want to make sure you write these examples down. We're going to identify the acid, base, conjugate acid, conjugate base, and the reactions below. And just to make sure we're clear, the acid loses the H, or will lose the H, and the base gains the H. So let's look at the first one, HCl and HOH. HCl will become Cl. So does it lose or gain an H? It loses an H. So my HCl is the acid, and then the Cl becomes the conjugate base because the acid becomes the conjugate base. I'm going to abbreviate, which means HOH, water, is my base. Now let's check and make sure, does it gain an H? Well, there's 2 hydrogens here, 3 over here. So yes, it gains the H. So it is the base and then the conjugate acid. And if this reaction was reversed, chlorine would gain an H because it would go from Cl to HCl. That's why we call them the conjugate base. Next one, NH3 plus HOH makes NH4 plus OH. And so we want to label acid, base, conjugate base. NH3, it goes from NH3 to NH4. So it's not losing an H, it's gaining an H. That is my base, which means NH4 is my conjugate acid. And then let's just double check. HOH, water, goes from HOH to OH. So yes, it loses an H. It is the acid and the conjugate base. So we see in these 2 reactions, water up here is a base, but down here it's an acid. It can act as either. It has a pH of 7. Water is both. It can do either, just depending on what it's paired with. So you can't always say with Bronsted-Lowry acids and bases, like this is 100% an acid, this is always a base, because it depends on what it's reacting with. Okay, so a little more practice. We're going to write the conjugate base for the following acids. Now let's review again. Acid loses an H. So the conjugate base is just, what is it when it loses an H? So HClO4, when it loses an H, now it's just ClO4, and it lost an H positive. It lost a positive charge, so it's 1 negative. H3, oh, I forgot, it's going to have that there. H3PO4. Now the conjugate base for that, they lose a H. They lose just 1 H. And so it becomes H2PO4. And notice that negative, the negative sign. They all have lost an H, so they have a negative charge. CH3NH3. This one is a little tricky. Where do we write where it lost the H at? I wouldn't expect you to do that one on your own, but it becomes CH3NH2. The H goes from the N. Again, I wouldn't expect you to remember that, but this time it doesn't have a charge because look, there's a positive charge right here. So it's already 1. So what happens when you minus 1? It's a 0. So it doesn't have a charge. Compared with these conjugate bases up here, they have a 1 negative charge because the acid didn't have a charge. So it's 0 minus 1, negative 1. That's what they have, a negative 1 charge, but because this was a positive 1, when you subtract 1, it's 0. No charge here. Okay, and then we're going to write the conjugate acid for the following bases. Now the base will gain an H positive. So Cn, and that is a negative symbol right there. When it gains an H, it becomes HCN. And then thinking about the charge, it's a negative 1 right now, but it gains 1, so plus 1. What's negative 1 plus 1? 0. There's no charge. And it's just HCl. Now, the next one, water, H2O. When H2O gains an H, now it's H3O. But thinking about the charge of water is 0. It doesn't have a charge on it. When you add 1, now it's got a positive 1 charge. So it becomes H3O, 1 positive. Oops, and that changed really fast, sorry. So that was the Bronsted-Lowry definition. We're just going to go over what the Lewis definition is. We're not going to draw or write any examples of these, so you just need to have this definition written. You don't have to, you're not going to be expected to like draw or predict like Bronsted-Lowry with these. So the Lewis definition, this is the newest acid-base definition. If you take AP chemistry, you'll do a lot with Lewis acids and bases. So Lewis acid is any substance that accepts an electron pair to form a covalent bond. And so looking at this reaction we have below, we have HCl plus water. And then it forms H3O positive and Cl1 negative. And so in this case, our HCl is the acid because it is actually going to take a pair from water to form this. I don't really need you to understand these examples. I just need you to know this part. It accepts the electron pair. And then a base. A base is a substance that donates an electron pair to form the covalent bond. And so NH3 is our base. Looking at this, it becomes this. It donates that lone pair to hydrogen, and they form a covalent bond. So Lewis definitions, acid accepts electron pair, base donates it. You're not going to be expected to draw these or write these or anything. And so here are the 3 acid and base definitions just summarized for you. Arrhenius is what we're going to deal with most of this unit. They produce H positive, an acid does, and then the base produces OH. Bronsted-Lowry will donate, the acid donates the H, the base accepts the H, and then Lewis, the acid accepts the electron pair, and then the base donates the electron pair. The 2 you really need to know are these 2. And so this is just a final review. Let's see how you do. Taste bitter, base. pH less than 7, acid. Taste sour, acid. Donates a proton, donates an H plus, acid. And what definition is that? Bronsted-Lowry. Feel slippery, base. A lot of soaps are bases, if you can remember that. Produces a hydroxide ion. Hydroxide is OH. Base. And that is the Arrhenius definition. Donates an electron pair. Base. Forms a conjugate base. No, this got messed up. There we go. Acid. Accepts the proton base. pH greater than 7. Base.